Hello, everyone. Good afternoon. Thank you for joining the seminar. Hope you enjoyed my presentation. Before starting my presentation, I would like to give my thanks to all the team members for this work. First, I would like to give my thanks to Professor John Gray, who is the chair of IGB UK and Ireland race chapter. Secondly, Professor Angela Kangrossi from the University of Manchester, who is a professor of machine learning and robotics. Professor Qin Meng from Loughborough University, who is a professor of AI and robotics. Professor Martin McGinnity from the Nottingham Trent University, who is a professor of intelligence systems, and Professor Jan Menon from the University of Strathclyde, who is a professor of advanced digital manufacturing. So the topic of my presentation is challenges and opportunities of AI for trustworthy robotic intelligence. This is a big topic. So today I just briefly introduce the work on this topic. So first, I will review some serious accidents in the real world. This accident give us a critical lesson to tell us how important a trustworthy autonomous system is. And then I will introduce some challenges for implementing trustworthy race. And I will show you the opportunity or power of AI for implementing trustworthy race. And then I will propose human acceptance to trustworthy race. Finally, I would like to highlight human-centered AI on the way towards trustworthy robots and autonomous system. As we know, AI has been developed very much since the concept of AI was coined by the 5 researchers at the Dartmouth College Conference in 1956. So today, the AI can be categorized to 7 patterns. The first is pattern and anomalies detection, hyper-personalization, recognition, conversation, and human interaction, predictive analytics and decision, goal-driving system, finally the autonomous system. In my opinion, all other 6 patterns could contribute to autonomous system to improve the system autonomy and its trustworthiness. So it can be said that AI is a means of improving the trustworthiness of robots and the autonomous system. With the development of robots and the autonomous system, we have experienced many accidents in the real world. Humans always optimistic to the new technology at the beginning, and also pursue the performance, functionality, and the quality of the system, but ignore the trustworthiness of race. So we have developed very much on the way towards the fully autonomous system, such as Google driverless car has passed the test of driver license, but it was reported that they still need an operator or a coach sitting inside to manage the cars in case any unexpected situation. For example, the self-driving car killed an Arizona woman, which is the first fatal crash involved pedestrian. Actually, the self-driving car was in autonomous mode at the time of crash, and the vehicle hit the woman who was walking outside of the crosswalk and later died in a hospital. there was a vehicle operator inside the car at the time of the crash, but he didn't drive the car. So the one of the possible reasons for this accident is the response speed. That means that the car might already recognize the pedestrian, but the response speed did not match the car speed. So before make right action, the car hit the woman. So this is a critical challenge. So the next example is the famous hacking experiments by two computer scientists on a jeep on a highway. And the two hackers developed a tool that can hijack a chip over the internet. While the senior writer Andy Greenberg took the jeep for a spin on the highway, while the hacker attacked it from miles away. So the two computer scientists actually are researchers of cybersecurity. So they are able to explore the security vulnerabilities in automobiles by hacking into the cars remotely, take the various control from the radio volume to the brakes and penetrate directly to the information system, and stop the vehicle at the speed of 33 miles per hour. That means a hacker can attack a vehicle arbitrarily if we do not redesign the system with the concern of cybersecurity. Another example is the two MAX 737 accidents, which totally killed 346 people. The first accident is an airplane crashed on the 29th of October 2018 after taking off in Indonesia, which killed 189 people. The second one is the Ethiopian Airlines crashed on the 10th of March 2019 after taking off in Ethiopia, which killed 157 people. One of the important reasons for the second accident is the sensor failures. From the picture here, the curve shows the left sensor work normally, but the second sensor in the right sensor didn't work at all. So this is a critical challenge, tell us sensing and perception of the system status is very important. Another reason for the accidents is the airplane shape design does not match the innovation of the airplane. Another example is in 2015 again, the German Wings flight 9525 crashed by suicide event by a pilot. 144 passengers and 6 crew members were killed. So it was reported that this accident due to a co-pilot, Angel Rubis, who had previously been treated for suicidal tendencies and declared unfit to work by his doctor, but he didn't report his situation to the company. So at the event, only he stayed in the cockpit and he locked the door. Nobody can enter the cockpit. He directly drive the airplane to hit the S, like this curve, we can see that. So after this event, European Aviation Safety Agency issued a temporary recommendation for airlines to ensure that at least 2 crew members, including at least 1 pilot, were in the cockpit for the entire duration of flight. This accident raises a question: how can we make an autonomous system to be aware of the human mind, to avoid any risk by human? So now let's see the NIST framework of cyber-physical system. Why I mentioned the framework of cyber-physical system? Because almost the robots and the autonomous system belong to cyber-physical system. So a cyber-physical system is comprised of 4 stages: physical state, information computing, decision making, and action, plus the human interaction, as this picture shows us. So the NIST framework of cyber-physical system can be applied for the robots and the autonomous systems. So from this picture, we can see that the first stage is physical state, but they didn't mention cyber state and also the external environment. The physical state could include the external environment, but also should include the system health state as well. So as a robot and autonomous system, it should be able to sense all the state anomalies from cyberspace, external environment, and the system itself, and to give the right decision and actions. So, and also should be allow human intervention at any execution point in case any situation happened. So this is a NIST framework of cyber-physical system to ensure the functionality and the performance of race, such as logicality, performance, quality, which are all supported by the system's autonomy. We identify 4 factors that are associated with race trustworthiness. So the first factor is the safety. Safety is the persistent requirement for all kinds of autonomous systems, and it should be co-designed with other factors. The second factor is a critical challenge, and cyber attacks could directly threaten the safety of an autonomous system. The third factor is the system health. The reliability and the safety of race face challenges from potential process abnormalities and component faults. The last factor is human-machine interaction, which refers to the communications and the interaction between human and machine through a user interface. Actually, human-machine interaction is related to functionality, performance, safety, and reliability. So we have identified the challenges of implementing trustworthy race. The first, let's see the challenges of race safety. The challenge of race safety lies in a huge variety of a working environment, because all the robots and autonomous systems need to adapt to the dynamic environment. The second, the robots and the autonomous system should sometimes need to synchronize their work to the other robots or humans in the collaborative teams. So which also is dynamic. We have the diversity and uncertainty potential failures in the system. So this also is a critical challenge, plus the requirement of early warning and fast response. That means the system should have the real-time performance. So the previous mentioned the Uber vehicle killed a woman on street. Probability reason is the real-time response issue. So it should allow human intervention at any execution point, which is a critical challenge. Another critical challenge is the ethics issue. Look at this picture, we can see that two vehicles crashed. One is driven by human, the other driven by automatically. So who will pay or take the responsibility when a driverless car crashes? So from this point of view, the regulation is highly demanded now. So now let's see the challenges of race security. Race security is a big challenge current, and also is a demand by Industry 4.0. I use a vehicle as an example to show how we secure an autonomous vehicle. Recall the previous example, the experiments by the two computer scientists. That means a hacker could attack such a system through any kind of communication channel, as because usually a vehicle is connected to the internet, and also in such a system there are several communication channels, such as mobile cellular network, Bluetooth, Wi-Fi, and a radio system. A hacker can attack the system through any kind of channels. And also in such a vehicle system, which is compressed a lot of components, most components are embedded system. They form an internal wide network. Those embedded systems exchange information through internal buses. Once such a system is attacked, all the components of embedded system could be compromised, will cause the malfunction of the system and affect the safety of the system. To secure such a robots and autonomous system, the critical challenge is secure the communication channel. Secondly, we need to secure the race software integrate, because any kind of mistake of the software will make a malfunction and affect the safety of the security race. Thirdly, we need to secure the hardware, which is a critical challenge because hardware is essential for the safety and the reliability. Now let's the challenges of race health. Look at this picture. This is the engine of Delta Airline Fighter 1288 after it experienced the catastrophic uncontained compressor rotor failures in 1996. There were over 13 notable uncontained engine failure accidents since 1973 to now. So, of course, we previously mentioned the MAX 737 accident also is belong to the health issue. So, the challenge of race health lies in the diversity and uncertain potential failures. So from the MAX 737 accidents, we know the correct sensing and perception is vitally important. At least 75 up to 100 sensors located in different places of an airplane, which is required a high accurate prognostics and real-time safe diagnosis with early warning and fast response. It also should allow human intervention at any point. Here, I would like to particularly mention that the inability to exhaustively test and verify a system is a critical challenge. To guarantee or ensure the safety, we need to have strictly test and verify the system before flying, but it's not possible. So which is a critical challenge here. Now let's see the challenges of human-robot interaction. And this challenge lies in the robot system is working in a complex physical world, which is a dynamic, non-deterministic, and partially unknown. Second challenge is the socially accepted response and common sense knowledge to handle a broad variety of situations with complex semantics to interpret and understand by robots. The third challenge is the diversity, complexity, and uncertainty of human state or mind, which brings critical challenges because a variety of human emotions expressed by different subjects with different education, different background, different cultures, and even different contexts. So this makes robots understand the critical challenge. Particularly, I want to mention here, the uncertainty of human mind is a critical challenge for human-robot interaction. As mentioned, that pilot suicide event, which is a critical challenge to let the autonomous system recognize the human mind. Again, the inability to exhaustive test and training such a complex system, human-machine interaction, is a critical challenge. So now let's see the power of AI and the opportunities of AI for implementing trustworthy race. First, let's see AI for the safety of race. So look at this picture, which is a passive monitoring system. In this monitoring system, human input also in the loop. So human intervention have been aware by all the industry and engineering. So this is a technical report by NASA. So in many safety critical race, like an airplane and UAVs, etc., require a safety instrumented system. One of the key functions of such a system is to detect anomalies through sensing their surrounding environment. Currently, advanced sensor technique can support this work. So the most frequently used sensors, including laser sensors, visual sensors, radar, GPS, infrared sensor, and ultrasonic sensor, etc. Different sensors could provide different types of data, and the different types of data require different AI techniques. For example, there's many evidence shows that deep convolution neural network is good for image-based problem. And actually, AI has contributed for diversity of tasks. For example, for the autonomous vehicle, static or dynamic obstacle detection, road sign recognition, human behavior recognition, accident response, and road shape recognition, etc. Here, I need to mention that real-time performance is a critical challenge. So the currently online machine learning training to adapt a dynamic environment is still not entirely solved, especially real-time performance. As I mentioned previously, the Uber killed a woman on the street. One possible reason is the response speed. So the real-time performance is everlasting code target. Now let's see the AI for the cybersecurity of race. Look at the right picture. We show the cyber-physical system there's 5 components: sensors, communications, actuators, storage, computing. All of these 5 components, some of belong to cyberspace, some of belong to physical space. No matter which space, all the components could be attacked by different cyber attack as shown in this picture. So cybersecurity of autonomous system is a critical challenge, and also security by design is required by the Industry 4.0. So in my opinion, security automation might be the only way to secure an autonomous system, because a human manual secure race is not possible. So that means AI and machine learning can be the key driver to implement security automation. This required us the security solution should be integrated to the architecture of a race. AI actually has contributed to cybersecurity in 3 aspects. The first aspect is access control. The pattern recognition has played an important role for biometrics identification, such as COM, iris, fingerprint, and face recognition, signature verification, keystroke pattern recognition, etc. The second aspect is anomaly detection, such as attacks, intrusions, crawlers, malware detection. And another aspect, human behavior monitoring, is also very important, because all hackers start their work from the social engineering. So if we have good human behavior monitoring, we can identify the threat or the attacks at the early stage. So there's another issue. AI model in a system is a program, like a generic program and a system program. So AI model could be attacked as well. So the security of AI model should be concerned when we design the system. There's 2 critical requirements for AI model. First requirement is AI should be robust and be able to avoiding overfitting to adversarial training examples. The other requirement is AI should be adaptive, self-learning, and autonomous. So this is the AI contribution to the security of race. Now let's see AI for health of race. Look at the right picture, which is analytical fault diagnosis. From this picture, we can see in a plant, there could be sensor failure, process failures, and actuate failures. All of these different types of failures might be represented by anomaly information. That means machine learning techniques can be applied for fault diagnosis based on the history anomaly information. So from this point of view, all the fault diagnosis can be divided 3 different types of tasks. First task is fault detection, which can be solved using decision-making techniques. Fault isolation, which can be used optimization techniques. And also fault identification can be solved using classification techniques. So there's many evidence shows AI and machine learning techniques have contributed for fault diagnosis. So usually we can divide 4 types of method: model-based, signal-based, knowledge-based, and hybrid models, which have been well addressed in the survey list here. So if you are interested, you can go for the more details about this. Now let's see the AI for human-robot interaction. Actually, AI for human-robot interaction is a critical challenge, but the AI has contributed for improving human-robot interaction in several aspects. We just briefly summarize the 4 aspects. The first aspect is AI is used to improve the robotics cognition capacity. For example, convolutional neural network is good for natural language processing, which will improve the robotic cognition capacity. The second part is robotic vision, which allow the robot to have a human eye capacity by adding visual understanding capacities. The third aspect is knowledge extraction and sharing between human and machines, for which machine learning techniques, especially computing in words, linguistic computing, and transparent rule-based reasoning, all of these techniques could contribute for the knowledge extraction and sharing between human and machines. The last aspect is knowledge representation. As we know, even we have a sensing system, all the information might be uncertainty. So fuzzy technology could be useful for the uncertainty of information to improve the computing and the decision making. So now let's see the human acceptance for trustworthy race. We can say that human acceptance decides the requirement of trustworthy race from human. There's many models have been developed, but so cybersecurity is a weak concern in the literature review. In this model, we represent the trustworthiness through 2 aspects. One is the worthiness, the other is the trustness. So the functionality or performance of a system is represent the worthiness. The reliability, human-machine interaction, safety, and privacy represent the trustness. So here I didn't show the security as a direct link to the trustness, as because the 4 aspects, reliability, safety, privacy, and human-machine interaction, particular represent the human benefits. So human will directly think about this benefit if we meet their requirement. So these 4 aspects directly linked to trustness. But the security, here I forgot a link from security to safety. As we mentioned before, the cybersecurity experiments. So security can directly threaten the safety of robots or autonomous system. So the 4 key factors actually, security, safety, health, and human-machine interaction, all of these 4 factors directly link to the reliability. And and also health will affect the safety and the human machine and the security. All of these 3 aspects will directly link with the safety of the race, and also the reliability link with the functionality of performance of race. So this is the human acceptance model for trustworthy race. So as we know, we are currently on the way towards the fully autonomous system, according to the PwC study, the current robotics intelligence can be divided to 3 levels. The first level is the assisted intelligence. For this level of robotics intelligence, AI has replaced many of the repetitive and standardized tasks done by humans. For example, the classical example is the automotive industry. So we can see that a lot of robotics arms working together to assemble the vehicles automatically. So sometimes we call the assisted intelligence as automation intelligence. The second level is augmented intelligence. So where the humans and the machines learn from each other and redefine the breadth and depth of what they are doing together. So for example, for the augmented reality could provide a heads-up display. Even they can show the patient information. That means the doctor can have the patient information on their heads-up display when they are doing the surgery. So this is the current, the latest research, the state of the art in surgery robots. The advanced and the highest level is the autonomous intelligence, where adaptive and continuous machines take over the whole process of perception, decision-making, and actions, independent of human intervention. The classical example is the autonomous vehicle. Human can work or play in the vehicle without any intervention to the vehicle. Of course, the vehicle should given the chance for the human intervention in case any situation, unexpected situation. So, as we know, the AI has been developed very much, and which is a means of improving trustworthiness of race. So, robots or autonomous systems should be able to perceive the outside environment and learning from the experience and reason from the condition, known conditions and adaptive unknown situation. So we always simulate the robotics intelligence to the human intelligence. I list some human intelligence here, like such as linguistic intelligence, visual intelligence, musical intelligence, logical mathematical intelligence, spatial intelligence, body kinesthetic intelligence, interpersonal intelligence, and emotion intelligence. All of this intelligence, I think the interpersonal intelligence and the emotion intelligence are more complex than other types of intelligence. Currently, the robots has achieved certain progress all for this kind of intelligence, but for the interpersonal intelligence and emotion intelligence still have a lot of work to do. For example, like the autonomous programmable robots, NO, which have already implemented almost all of this in individual intelligence. So of course, there's still a lot of work to do. As we know, humans have two significant capacities. The first capacity is reasoning converts the information and make decision in an environment of imprecision, uncertainty, incompleteness of information, and partiality of truth and possibility. The second capacity is to perform a wide variety of physical and mental tasks without any measurements and any computations. So for the first capacity, we believe we have achieved a certain progress. Like I mentioned, the the robot know, so already implement some of the capacity. But for the second capacity, is still long journey, which is a critical challenge, not critical challenge, but also is a massive work and may need many more generations of research and innovation. That means we still have a long journey to make robotics intelligence to the human intelligence. So we will only have partially the capacity for the first capacity of a human. So no matter which kind of or which level of the robotics intelligence, so we need to notice that the purpose of developing human-centered AI to implement a trustworthy race is to augment human capacity. So we can imagine that in the future, we might, in such a scenario, human and robots collaborate each other to extend our capacity. So from this point of view, race should effectively communicate and collaborate with the human. So each partner will bring its superior skill to the partnership. Robots extend the human capacity, and the human brings our skill to support the robots. So we do not seek AI that will supersede human or human intelligence, but we use AI to augment the human and human intelligence. From this point of view, human-centered artificial intelligence system can amplify existing and creating new human skills and capacity. And from this point, we will have augmented capacity and also offer the new experience. That means even robots take over some activities of human, but human might need to have redefined job to collaborate the robots and even manage the robots or control the robots. So this is my point. So any robots and autonomous system should only be the extension of human capacity or human intelligence. As we talk about, robots might take over many human activities, but this doesn't mean robots can replace and control humans. So we need to be cautious when we develop a fully autonomous system. So we need to follow the regulation. Here, again, I need to emphasize regulation is very important. We need to follow the regulation and avoid any superior intelligence. When we develop a fully autonomous system, we should have a solution allowing humans to interrupt the robot's work at any points. That is what I mentioned many times before. So we, all the citizens, scientists, and engineers should get together to undertaking AI-driven mission-based innovations and avoid any weaponization of AI, which is the biggest threat of AI to human and the earth. So we need to develop robots and autonomous system to help humans to work in extreme and hazard environment and improve the capacity of health and social care and augment the capacity of manufacturing or and food production, reduce the damage to the earth, help recover the damage we have done to the planet and explore space. Particularly, I still want to emphasize is we need to avoid the weaponization of AI. So all the citizens, scientists, engineers work together to take this work on the AI driven and mission-based innovation to keep our sustainable planet and human being. Particularly, we need to focus on the impact of AI on humanity. So now I would like to recall the ASMO 3 laws of robots, which was proposed in 1950. The first law is a robot may not injure a human being or through inaction allow a human being to come to harm. Second law is a robot must obey the orders given it by human beings, except where such order would conflict with the first law. The third law is a robot must protect its own existence as long as such a protection does not conflict with the first or second laws. So maybe somebody say the ASMO 3 laws of robots are outdated, but in my opinion, the ASMO 3 laws of robots are still applicable and are essentials. Of course, today we might have more concern based on these 3 laws of robots. Previously mentioned the accident of the German wings flights. So the pilot suicide event, particularly against the second law and the third laws of robots. So now I would like to conclude my presentation, use this diagram. So when we develop a race with the purpose of improve the performance or functionality, so we need to consider safety, security, health, and human-machine interaction. There's a lot of machine learning AI technologies can be used for this purpose, such as perception, reasoning, learning, linguistic, visual, and emotional technology. So here, the human-centered artificial intelligence should be the core of the development. When we make effort to implement the robotics intelligence towards the human intelligence, we need a particular notice that robotics intelligence is only the extension of human capacity or augment human capacity. We particularly need to focus on AI's impact on humanity. Thank you very much for your attention. After our work, we have raised the special issue in IEEE transactions on cognitive and developmental system, artificial intelligence and edge computing for trustworthy robots and autonomous system. So this special issue covering six themes. First is AI and edge computing for the cybersecurity of race. Secondly is for safety of race. Third is for the health of race. And the fourth is for the interaction of race with humans. So these particular is the 4 aspects I have discussed before. And the fifth aspect is improve the performance of race, which is the purpose of we develop robotics and autonomous system. And the last one is very important, the architectures of trustworthy race enabled by Internet for robotic things. So you are welcome to share your innovative research outcome through the special issue. The deadline is the 1st of December 2020. Thank you very much. Any questions?